Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today problem again about momentum playlist, so look in the description for the link to understand better what's going on. So this time, and this is railroad, I look from the top and there is a cart, M, capital. And M is given and M is, let's say, 200 kilogram. And then it's moving with the speed V. V1, V initial. And V initial, let's say, 8 meters per second. And then there is a man who jumps. This is alpha. And alpha is 30 degrees. And it jumps in this direction. After it jumped, it has the speed U. And U is given, right? And U is 7 meters per second. And, U, they want to know the U, but they tell you that after he jumped, the cart started to move with the speed V2. And V2 is 7 meters per second. That's what they tell us. And they want to find out what would be the speed of this jumper. And how we solve this problem? We say that this is one-dimensional movement this direction, and the fact that the man jumped here is because he pushed himself. He pushed himself in this direction, and there are two projections. And projection in this direction, horizontal, because remember, we look on the railroad. This is all railroad. And those are rails. And this is how it moves. And so, in this direction, the system is not a closed system. But in this direction, it's a closed system, so the law of conservation of momentum applies, and I forgot to tell you that the mass of the person is given, of course. So, before, everything was m plus m, total mass, and there was a speed v1, and it was initial momentum. After the man jumped, the cart m started to move with speed v2. So remember, the law of conservation of momentum is a vector law. So in this direction the system is not closed. But in this direction the system is a closed system. So that's why we're calculating this momentum on this axis. So after the man jumped, this was the momentum of the cart. Remember, in the beginning it was the cart and the man, so it was m plus m, but in the end it's only the cart that's moving with reduced speed of 7 meters, right? So mv2, and then I have to take in consideration the momentum of the jumper itself. This would be mu cosine alpha. So because the projection in this direction is u cosine alpha. If you confused, go to my pre-request vector playlist, and it's all explained how we get the projections. And so what we know, m is given, m lowercase is given, v1 is given, m uppercase is given, v2 is given. So m lowercase is given, u is unknown. Yes, u is unknown, and cosine alpha is given. So everything is fantastic. When put mu cosine, leave it there because it's with positive sign, and we put m plus m v1 minus m v2 equal mu cosine alpha. And we change sides, so I write mu cosine alpha first, and I put the rest would be m, I can open brackets, v1 minus m v2, I write this first, plus m v1. I open brackets and change the order how I write things. And then I put mu cosine alpha, and I have m v1 minus v2 plus mv1. Why I do so? I just did so to emphasize that there is a change in momentum related to the cart itself. The cart has the mass m no matter what, and its momentum changed because it was v1 and it became v2. Now also there was momentum related to the person sitting on this cart and riding with the speed v1. So this is how it is. And then this is what happened after he jumped. It's for a little bit advanced thinking, but for now all I'm doing, the physics ended here, right here. This is physics end, and mass starts, one equation with one unknown, and we of course can get it. And this is mv1 minus v2 plus mv1, and divided into m cosine alpha. And let's put the numbers. We'll have m is 200, v1 minus v2, 8 minus 7 is 1, plus mass 70, 70 multiplied by 8, and the bottom would be, mass would be 70, right? And cosine alpha, this is cosine alpha again. Look to the trigonometry playlist. It would be square root of 3 over 2. It would be 1/7 divided over 2. It would be 0.85 approximately. So it would be 0.85. All right. So then we will have 200 plus 70 by 80, 560. So I continue writing here equals 200 plus 560. And this would be divided over 70. 7 by 8 would be 560 plus a little bit 70, what would be roughly 60. So it would be 760 divided over 60. 760 divided over 60, it would be roughly 12 meters per second. 12 meters per second is quite a speed. So the man jumps with 12 meters per second, it's about 40 kilometers an hour roughly, or maybe a little more even. In this direction it's a lot of speed, and this causes this massive cart to slow down from 8 to 1 meter per second. So that's all with this problem. Don't forget to like, subscribe, bell. If you have a question, don't hesitate to ask. And if you want your problem, put it in the comment section. Thank you.